Preparing for a front-end developer interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What happens in the browser from entering a URL to seeing the page rendered? I break it into network and rendering phases. The browser resolves DNS, opens a TCP connection, negotiates TLS for HTTPS, then requests the resource. After receiving HTML, it builds the DOM, downloads CSS to create the CSSOM, and combines both into a render tree. Then it calculates layout, paints pixels, and composites layers. JavaScript can pause parsing unless deferred or async, so script loading strategy directly affects perceived performance. While answering, focus on DNS lookup, TCP TLS, HTTP request response, HTML parsing, CSSOM, render tree, layout, paint, compositing, and how JavaScript can block rendering. Question 2. How do you explain the JavaScript event loop, microtasks, and macrotasks? The event loop lets JavaScript stay single-threaded while handling asynchronous work. Synchronous code runs on the call stack first. Macrotasks include set timeout, set interval, and DOM events. Microtasks include promise callbacks and queue microtask. After the stack clears, the browser drains all microtasks before taking the next macrotask, which is why promise.then usually runs before set timeout with 0 delay. Understanding this helps debug race conditions and UI update timing. Make sure to cover call stack, task queue, microtask queue, promises, timers, rendering timing, async behavior, and why promise callbacks often run before set timeout callbacks. Question 3. What is the difference between var, let, and const in JavaScript? Var is function scoped and hoisted with an initial value of undefined, which can create subtle bugs. Let and const are block scoped and also hoisted, but they stay in the temporal dead zone until declaration. Let allows reassignment. Const does not allow rebinding. However, const objects can still have their properties mutated. In modern front-end code, I default to const, use let when reassignment is required, and avoid var. In your answer, talk about function scope versus block scope, hoisting, temporal dead zone, reassignment, mutation of objects, and why modern code prefers let and const. Question 4. How would you optimize a slow front-end application? I start by measuring, not guessing. I use Lighthouse, Web Page Test, Performance Panel, and React DevTools if relevant. Then I look at core web vitals, LCP, INP, and CLS. Common fixes include compressing and resizing images, code splitting, lazy loading routes, reducing unused JavaScript, caching static assets, and avoiding expensive re-renders. I also inspect long tasks and network waterfalls. The best optimization is usually the one users actually feel. Be sure to mention measuring first, core web vitals, bundle size, lazy loading, image optimization, caching, avoiding unnecessary renders, code splitting, and profiling with browser tools. Semantic HTML means choosing elements based on meaning, not appearance. For example, I use button for actions, nav for navigation, main for primary content, and article for standalone content. This improves accessibility because assistive technologies understand page structure and controls correctly. It also helps SEO and makes the code easier to maintain. Styling can still be done with CSS, but the HTML should first describe the content and behavior accurately. While answering, cover meaning-driven markup, accessibility, screen readers, SEO, maintainability, examples like header, nav, main, article, button, and avoiding div-only layouts. Question 6. How do you make a web application accessible? Accessibility starts with semantic HTML and keyboard-friendly interactions. I make sure every interactive element can be reached and operated with the keyboard. Visible focus states are present, and forms have proper labels and error messages. I use area only when native HTML is not enough. I also check color contrast, image alt text, and screen reader behavior. A good rule is, build with native elements first, then enhance carefully. Make sure to cover keyboard navigation, focus management, semantic HTML, ARIA only when needed, color contrast, labels, alt text, screen reader testing, and WCAG principles. Question 7. Explain the CSS box model and how box sizing changes layout behavior. The CSS box model describes how an element's size is calculated: content, padding, border, and margin. With content box, width applies only to the content, so padding and border increase the final rendered size. With border box, width includes content, padding, and border, which makes layouts easier to reason about. Most projects set box sizing border box globally because it reduces unexpected overflow and makes component sizing more predictable. In your answer, talk about content, padding, border, margin, width calculations, box sizing, content box versus border box, layout predictability, and why teams often reset globally. Question 8. When would you use Flexbox versus CSS Grid? Flexbox is best for one-dimensional layouts, either row or column, like nav bars, button groups, and aligning items inside a card. Grid is better for two-dimensional layouts where rows and columns matter together, like dashboards, galleries, and full-page shells. I often combine them: Grid for the page structure and Flexbox inside components. The decision depends on whether I'm distributing items along one axis or controlling an entire layout matrix. Be sure to compare one-dimensional and two-dimensional layout, alignment, wrapping, content-driven versus layout-driven design, practical examples, browser support, and combining both approaches. Question 9. What is event delegation, and when is it useful? Event delegation uses bubbling to handle events from child elements at a common parent. Instead of adding a click listener to every list item, I attach one listener to the list and inspect event target to find the clicked item. This is efficient for large lists and works well when elements are added dynamically. The main caution is to match targets carefully and avoid breaking behavior with unnecessary stop propagation calls. While answering, focus on event bubbling, attaching one parent listener, dynamic child elements, performance benefits, target matching, stop propagation risks, and use cases like lists or tables. Question 10. How do you handle state management in a complex front-end application? I first classify the state. Component-only UI state should stay local. Shared UI state can use context or a lightweight store. Server state is different. It needs caching, refetching, loading states, and error handling. So tools like React Query are often better than putting everything in Redux. URL state belongs in query parameters when it affects navigation. My goal is to keep state close to where it is used and avoid global state by default. Make sure to cover local versus shared state, server state, derived state, URL state, context, Redux or similar tools, caching libraries, and avoiding over-engineering. Question 11. What causes unnecessary re-renders in React, and how do you reduce them? Unnecessary re-renders usually come from parent updates, unstable props, or state placed too high in the tree. Objects and functions created inline get new references every render, which can defeat memoized children. I reduce this by co-locating state, splitting components, using stable keys, and applying React.memo, use memo, or use callback only where profiling shows value. Memoization has overhead, so I treat it as a targeted tool, not a default habit. In your answer, discuss parent renders, changing object references, inline functions, memoization, React.memo, use memo, use callback, key usage, profiling, and when optimization is premature. Question 12. How would you design a responsive layout that works across mobile, tablet, and desktop? I usually start mobile first because constraints force clear content priorities. I use fluid containers, relative units like REM and percentages, and media queries to enhance layouts as space increases. Images should use responsive techniques like src set and sizes to avoid downloading oversized assets. I also check touch target size, typography scaling, and navigation behavior. Testing in DevTools is useful, but I still verify on real devices because viewport and input behavior can differ. Be sure to mention mobile-first CSS, fluid layouts, relative units, media queries, responsive images, touch targets, content priority, testing real devices, and avoiding fixed widths. Question 13. What are closures in JavaScript, and where do you use them in front-end code? A closure is when a function remembers variables from its lexical scope, even after the outer function has finished. In front-end code, closures appear in event handlers, callbacks, debounced functions, and React hooks. For example, a click handler can access configuration or state defined outside it. They are powerful for encapsulation and private state, but I'm careful with long-lived closures because they can keep references alive and contribute to memory leaks. While answering, cover lexical scope, functions retaining access to outer variables, private state, callbacks, event handlers, hooks, common loop pitfalls, and memory considerations. Question 14. How do async, defer, and normal script loading differ? A normal script blocks HTML parsing while it downloads and executes. Async downloads in parallel and executes as soon as it is ready, which can interrupt parsing and does not preserve order. Defer also downloads in parallel, but waits until HTML parsing completes and preserves script order. For application bundles that depend on DOM structure or other scripts, defer is usually safer. Async is better for independent scripts like analytics or ads. Make sure to cover HTML parsing behavior, download timing, execution order, render blocking, dependency scripts, analytics use cases, and why defer is often safer for app bundles. Question 15. How do you secure a front-end application against common web attacks? Front-end security is mostly about reducing attack surfaces. For XSS, I avoid injecting raw HTML, rely on framework escaping, sanitize trusted rich text, and use a strong content security policy. For CSRF, I prefer same-site cookies plus CSRF tokens where needed. I avoid storing sensitive tokens in local storage when possible and use secure HTTP-only cookies for session tokens. I also keep dependencies updated and treat client-side validation as user experience, not real security. In your answer, talk about XSS, CSRF, secure cookies, CSP, input validation, output encoding, avoiding unsafe HTML injection, dependency scanning, authentication token storage, and HTTPS. Question 16. What is the difference between local storage, session storage, cookies, and IndexedDB? Local storage persists across browser sessions. Session storage lasts per tab session, and both are synchronous key value stores. Cookies are smaller and sent with HTTP requests, which makes them useful for sessions, but risky if overused. IndexedDB is asynchronous, larger, and better for structured offline data. I avoid storing sensitive data in local storage because JavaScript can read it after XSS. Storage choice depends on lifetime, size, access pattern, and security requirements. Be sure to compare capacity, lifetime, synchronous versus asynchronous APIs, server transmission, security properties, use cases, performance implications, and sensitive data concerns. Question 17. How do you approach form validation and error handling in the front end? I treat front-end validation as fast feedback, not the source of truth. Basic checks like required fields, formats, and length can run client-side, while business rules must be validated server-side too. I show errors near the relevant field, associate messages accessibly, and avoid clearing user input after failure. For async checks, like username availability, I debounce requests and handle loading states. Good forms make correction obvious, without trapping the user. While answering, cover client-side and server-side validation, accessibility, inline errors, debouncing, schema validation, touched state, async validation, disabling submit carefully, and preserving user input. Question 18. How would you test a front-end component before shipping it? I test behavior more than implementation details. For a component, I write unit or integration tests around user actions and visible output, usually with testing library. I mock network boundaries when needed, but keep critical flows covered with end-to-end tests in Cypress or Playwright. I also check accessibility states and visual regressions for UI-heavy components. The testing pyramid still matters. enough coverage to catch regressions, without creating brittle tests that slow every change. Make sure to discuss unit tests, integration tests, end-to-end tests, accessibility checks, visual regression, mocking APIs, user-focused assertions, edge cases, and confidence versus maintenance cost. Question 19. What role does a bundler like Vite or Webpack play in a front-end project? A bundler turns source code into optimized assets the browser can load efficiently. It resolves modules, transpiles modern JavaScript or TypeScript, processes CSS and images, and creates production bundles. Modern tools also provide a dev server with hot module replacement, which speeds up feedback. In production, bundlers help with minification, tree shaking, content hashing, and code splitting. The goal is a smooth developer experience and smaller, cache-friendly files for users. In your answer, talk about module resolution, transpilation, bundling, tree shaking, code splitting, asset processing, dev server, hot module replacement, environment variables, and production optimization. Question 20. How do you handle API loading error and empty states in a front-end UI? I design API states as part of the feature, not as afterthoughts. Loading states should communicate progress without causing layout jumps. Skeletons work well for predictable content. Errors should be actionable, with retry options where appropriate. Empty states should explain what happened and guide the next step. I also handle request cancellation and stale responses to avoid race conditions. For complex server state, I prefer a caching library instead of hand-rolling every edge case. Be sure to mention user experience, loading indicators, skeletons, retries, error boundaries, optimistic updates, empty states, cancellation, race conditions, and separating server state from UI state. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.